is now o'clock here. Michel, are you ready?
Yes.
Okay. Hello, good morning to our North American and South American colleagues, and good evening to our European colleagues, and a good afternoon to our European colleague, and good evening to our Asian colleagues. I know our friend Yoshi Saito-san is here from Japan, and many students and colleagues from China, and somebody from Israel, from Europe, from Brazil. So welcome again to this World River and Delta System Source to Sink webinar. And today is the number 31 in 2021. So we invite Professor Michel Michaelovitch from University of São Paulo come here talk about the sediment source and the pathway of Rio de la Plata. Particularly, he will use neodymium and lead isotope to study the sediment in southern western Atlantic margin. So before I introduce Michel, so I want to mention to you this coming Friday, we have another great talk we are giving by Professor Karl Stetek from, he's retired, but he's now also a professor in Poland. And so he will also talk about South America river delta system. One is Panama and the San Francisco River Delta. And this is two very famous deltas in South America. And so please mark your calendar and coming here this Friday is May 7th. Same time is 9 a.m. in East Coast, 10 a.m. in Brazil, São Paulo. So, okay, Professor Michel Michaelovitch is now, as we mentioned, is professor at University of São Paulo. And actually, he also get a PhD there. And so he are visiting research in Rainfall, and also adjunct professor University of Massachusetts, Dartmouth in 2013 and 16. And since 2005, is a full professor in the University of São Paulo until now. He's a marine sediment chemistry, marine sedimentologist, also use a geophysics tool to study the sediment distribution. So Michel, so now you can share your screen for the presentation mode. We're looking forward to your talk.
Good morning. Thank you, Paul, for the opportunity to talk about this subject. I see that I have several friends here from Israel, from Japan, and for me it's a pleasure and an honor to be here. I must say that of course this subject I didn't do alone. This is a joint effort by colleagues from the University of La República in Uruguay, from the Argentinian Navy's hydrographic service from Argentina, of course, and a colleague who is presently at the University of Connecticut, who is a physical oceanographer. So I will talk about a very, very large area. This large area ranges from 23 south to 55 south. It goes from this region, which is known as the Cabo Frio, Cold Cape, to the Tierra del Fuego, to the southernmost part of Argentina. So we will talk afterwards. We will talk about the samples collected in all along this area. But first of all, First of all, I would like to talk about something about circulation in this area, and some aspects, some geomorphological aspects. Well, this area encompasses. This area encompasses the second largest river basin in South America. So, which is I will show afterwards, which is the Rio de la Plata, Paraná, and Uruguay system, which is the estuary is located here in between Uruguay and Argentina. This is one aspect that must be observed. But first of all, I would like to tell something about the circulation, because actually we'll see that the circulation in this area plays a main role in the sediment distribution. Okay, so from the south we have a shelf current which carries the subantarctic shelf water. So this water moves to the north and goes and is transported up to Uruguay. Here we have a very important current, which is the Malvinas or Falkland current. The displacement of the Malvinas current forms this way. It follows approximately the middle slope, and when it reaches this location at 37 degrees, it is displaced towards the east. Its counterpart is the Brazil current, which flows in this direction to the south, and when reaches also the Brazil Malvinas confluence, it also moves to the east. On the shelf, we have at least in a part of it, we have a general movement towards the south, but we will see that coming from the Rio de la Plata, we have another current that moves to the north. Another important aspect that must be seen here is that at intermediate waters, I mean from 800 to 1,200 meters, we have a current which belongs to the subtropical South Atlantic gyre, and this current, this movement, when it reaches the South American margin, it bifurcates in what is known as the Santos bifurcation. Okay, from the Santos bifurcation, this intermediate water, it forms a current, a counter current, because the Brazil current goes through the south. This current goes to the north at intermediate water, and to the south of the Santos bifurcation, we'll have a whole water column of, let's say, more than 1,500 meters of water flowing towards the south. I ask you to pay attention about this, because we'll need to know, or we'll need to understand this current in terms of sediment distribution. Okay, so in this sense, we can say that we have three important fronts: the Brazil Malvinas confluence, the subtropical shelf front here, which is a front that marks the boundary between this water from Argentina against the water from Brazil, and finally the Santos bifurcation here. Okay, so the main question of this research, and it's a subject that we are working together, and also, for instance, in this image I got from a paper that I worked with Uri Shatner from University of Haifa, is what are the sediment sources responsible for the late Cenozoic buildup of the upper margin? So this is the main question. I must say that I'm not a geochemist, I'm not a geophysicist, I'm a sedimentologist, but I try to use geophysics and geochemistry as tools for comprehension of the sedimentary distribution. Well, there were some previous works. One of the first works was done by Campos et al. And published in a special issue of Continental Shelf Research. And at that time, they worked with mineralogy. Okay, and I must show one of the main findings was the fact that they found a difference. This is the Rio de la Plata here, and this one is the Cabo Frio. And for instance, when you see the kaolinite distribution, they see a boundary between low kaolinite and high kaolinite values, more or less close to the subtropical shelf front. So what they argued that these sediments, which are poorer in kaolinite, they come from the Rio de la Plata estuary, and those ones richer in kaolinite, they come from the north, transported by the Brazil current system and other current systems which moves towards the south. So there was another work by Nagai et al. That used also mineralogy, and they reached the similar results. The difference between those two papers is the fact that Nagai used samples more widely distributed than samples by Campos. So there is another work by Hazik, and he proposed, so probably it was the first, this is from 2015, this was the first, he proposed a model of transport of sediments using other proxies such as magnetic particles. Well, there are some problems. I must say that there are some problems regarding these models, because particularly related with the transport of the intermediate waters. So I must say that I agree with some findings, but other ones are against what we know about circulation in this margin. Especially in terms of the flow of the intermediate waters. Okay. So with such a big area coming from 23 to 55 degrees south, we must expect a very complex lithology. Okay. So in the Brazilian coast, here, we have Precambrian high and medium grade metamorphic rocks and granites here. I will talk about this area afterwards, but I must say that there is a coastal mountain range that is facing the Brazilian coast from 27 more or less to more than 22 degrees south. In the interior here, we have a Paleozoic to Mesozoic sedimentary basin, which is the Paraná basin. Part of this basin is covered by toleitic basalts that were flooded just before the opening of the Atlantic Ocean. We have other outcrops of Precambrian rocks in the Uruguayan territory here. To the south, we have very extensive Cenozoic plain in Argentina. But one aspect that must be observed is that behind this plain, and this plain is fed by rivers that are originated from the Andes Cordillera. So we must understand that the Andes may be also a potential source of sediments towards the South Atlantic, even if they are located more to the west of the continent. So in terms of potential source rocks, we have high-grade metamorphic and granites. We have Paleozoic sediments and Mesozoic basalts here. We have Cenozoic sediments covering the Argentinian territory, and we have also volcanic rocks from the Andes. So taking a look at the landscapes and moving from the south to the north, these photos are not mine, but when we go to Patagonia, to southern Argentina, what we see are those huge cliffs, and these cliffs are actually being eroded, and nowadays they are formed by Cenozoic marine terraces that are being eroded, and some estimates by Isla and Cortizo, they estimate that about an erosion of 217 million of tons per year of these cliffs. Particularly, I think this number is overestimated, but I don't have elements to discuss this more. This would represent 10 times what is calculated of the sediments that are transported from the largest Patagonian rivers. And these largest Patagonian rivers, they bring sediments from the erosion of the Andes presently. So this is for Argentina. This is for Argentina. Another potential source of sediments to the southern marge, to the southern area of this wide area, is volcanism. And this what I show here is an ash plume derived from the eruption of the Calbuco volcano that occurred in 2015. And the Calbuco volcano is located in Chile, so facing the Pacific, but this ash plume is transported by the westerly winds that blow in southern South America. And you can see here. This is the Argentinian coast facing the Atlantic, and what you see here is that despite the volcano is located to the west, the plume crosses all of the South American continent due to these strong winds, and these ashes are potentially deposited in the Argentinian margin. One aspect that I forgot to comment here is the fact that despite this huge amount of sediments being eroded from these cliffs, apparently, most of these sediments eroded remained close to the coastal zone and feed the Patagonian beaches. So apparently the export of sediments towards the margin is less important, apparently. So coming back to the volcanic ashes, this is an image also associated with the Calbuco volcano. This is in the coast of Argentina, and you see here all of these boats are covered by ash, and they are located in the other side of South America. So just to give you an idea of the potential of export of these sediments, even though the volcanism is in this case an episodic event. But we also must say that there is not only one volcano in the Andes, and not only one active volcano in the Andes, but several of them. Well, now going to the main source of fluvial sediments to the area, just to show this darker area here corresponds to the area covered by what we call Paraná, Uruguay, and Plata basin. Actually, what is called the Rio de la Plata is just the estuarine area at the end of the course of the Paraná and the Uruguay rivers. So the Paraná River receives water from the Andes through the Salado, Bermejo, and Pilcomayo rivers, but also receives water and sediment from the Paleozoic, Mesozoic basin, from the Paraná basin, receives water and sediments also from Paraguay and Bolivia to the north, and receives water and sediments from these Precambrian metamorphic terrains that face the southeastern Brazilian coast. The main aspect here is that since we have a coastal mountain range facing the shore from 22 degrees south up to 28 degrees south, so most of the rivers from southern and southeastern Brazil, they run towards the interior of the continent. So they don't run directly to the ocean, but they run to the other side, and they feed the Paraná system, and the end of the Paraná system is the Rio de la Plata, which is located about 36 degrees south. And so what we see here is that we have sources from different types of rocks, and from distinct latitudinal sources. Okay, so just to let you know, so the size of this basin is more than 3 million square kilometers. Okay. Of course, these numbers are not compared with the Amazon basin, but the Amazon, I should say that the Amazon basin is another galaxy, another planet. It's another dimension for everything. So this is a satellite image of the Rio de la Plata. So the end of all of that system. Here is the city of Buenos Aires. Here is the city of in Argentina. Here is the city of Montevideo in Uruguay, and you can see here it's in the border of the figure, but there is a delta, which is called the Paraná Delta. So there is a delta which is formed inside this estuarine complex. Just to give you an idea. the maximum width of the estuary mouth is about 270 kilometers. So you can see here the plume of sediments going out from the Rio de la Plata. The average discharge of water of the Rio de la Plata is about 22,000 cubic meters per second. The suspended sediment load, it's about 160 million tons per year. And the coarser material, so especially silt and clay that leaves the system, and coarser material is retained here in the inner estuary. I mean, in the close in the vicinities of the delta. Well, still talking about this plume, and it's a plume of fresh water reaching the ocean and carrying suspended material here. So the physical oceanographers defined fresh, less saline water mass, which is called the Plata plume water. You see here that this Plata plume water, it's moved towards the north, and it follows a channel, which actually is the paleo channel of the Rio de la Plata. It follows a channel in the inner shelf, and this plume is transported towards the north. Okay, here you have the subtropical shelf front. Here, the subtropical shelf front is located beyond the 40 meters isobet, so it's not a superficial feature, but a subsuperficial feature, while the Plata plume water, due to the low salinity, is a superficial flow. Here you have also the Brazil current and the Malvinas current and the confluence in this area. So still moving to the north, we have the Rio de la Plata here. When we move towards the north, towards the Atlantic coast of Uruguay and the southernmost part of the Brazilian coast, we start to see some lagoons. This is the most important of them. It's called the Patos. Pato means ducks, so it's the Patos Lagoon, and but you can see here that there are several of those lagoons along the coast, either of the Atlantic margin of Uruguay or the southern Brazil coast. Some of those lagoons, such as the Patos Lagoon, some of them have open access to the ocean, and some of them, especially the Patos Lagoon, also exports some fresh water and to the ocean, and also it adds fresh water to the so-called Plata plume water here. Okay, so some of other lagoons also have present connections to the sea. And one aspect is that those lagoons are they occupy depressed areas between beach ridges that were developed under previous high stands. Okay, so still moving, we are still moving, and these landscapes in some areas there were dunes that appear. Some of them are 60 meters in height, and some of them are active. So some of them still are not fixed, and they are even eroded by the strong dynamics, the strong wave dynamics of the area. So moving towards the north, we start to see some hills, which marks the starting of that coastal range, the Serra do Mar range. So the landscape changes to estuarine systems. Those estuaries are especially from the, let's say, from 26, 27 degrees, they are bordered by mangroves. Some of them are very, very exuberant. And also what you see here are mangroves and the Atlantic rainforest. So it's the beginning of what we call Serra do Mar. Serra do Mar means sea range. And so when we move to the north and we reach to the limit of our study area, we see that the mountains, they literally go into the ocean. So some of those peaks reach 1,000 meters in height, and this changes totally the landscape, because here we don't have big rivers, but they're very, very small rivers that are controlled by the rainfall. And in this area, the rainfall can be as high as in the Amazon forest. So we have a place here in close to my office, I must say, that it rains literally every day. So the value is about 4,000 millimeters per year. So it's a huge number. It's comparable to the Amazon rainforest. Okay. So this is one view of those. Some of this, the plains are very, very limited. We in some places we have only pocket beaches like this. The drainages are very limited, but it's an area that it rains a lot, and there is no a big river, but several small ones. Okay. Well, one of the approaches that we are using to try to understand the source of the sediments is to analyze the isotopic composition of neodymium and lead. Okay, so we were able to analyze 155 sediment samples, and in this case, we will show the results only of the core tops of box cores and of multiple cores. So the latitudinal range is, as I said before, from 23 to 55 degrees south, and we analyzed the 206, 207, 208 ratio of lead, and the 143, 144 ratio of neodymium. In the case of neodymium, what we reach an index, and what you see here are the box plots for each one of those isotopes: neodymium, epsilon neodymium, 206, 207, and 204. And the first aspect that we see here is that first we applied an analysis of variance in order to see if there are statistically significant differences between each one of the sectors. So we defined the sectors: Argentina, Rio de la Plata, the region of Uruguay, southern Brazil, southeastern Brazil. And what we see is that except for 206 isotope, there is a significant difference of all of the other isotopes. Okay. So in this figure, we show the latitudinal variation of neodymium, epsilon neodymium, 206, 207, and 208. And the most marked variation is observed in the neodymium, in which we can see from Argentina the values are less negative, and as in general, we must understand that the less negative value, the youngest is the rock. Okay, the youngest is the source rock. Okay, and then this would mean that in Argentina we have younger, much younger source rocks than, for instance, in southeastern Brazil here. Okay, so here we are in southeastern Brazil, here we are in Argentina. And when we see the other distributions, they are not as clear as for the neodymium, but still we have some variations in 2007 and 2008 lead isotopes. I would like to show you this break in the distribution here, that corresponds to the Rio de la Plata region. Okay, so taking in account that variability and considering that the 206 lead isotope didn't show any statistically significant difference between the compartments, what we did was to make a multivariate analysis, which is a discriminant analysis. And when we put the values of when we perform the discriminant analysis, this allows us to recognize which variables are responsible for which sediment sample distribution. Okay, and what we see here, we see that these are the samples from Argentina, and we have from when you see Punta del Este here, when you see Punta del Este, means Uruguay. So we have samples from Argentina, then which are the most, which present the less negative value of epsilon neodymium, moving to the samples from Uruguay, then moving to the samples from southern Brazil. These are these brown X's here represent the samples from the Rio de la Plata, which actually are mixed with those ones from southern Brazil, and these, the green ones, are the samples from the southeastern Brazil, from Santos Basin. So what we see here is that there is a very, very important gradient that can be explained not only by the neodymium isotopes, but also by the 207 and 208 lead isotopes. So the epsilon neodymium, the less negative, corresponds to the Argentinian and Uruguayan, but to the other side, the more radiogenic 207 and 208 correspond to the samples from southeastern Brazil, from the Santos Basin. Well, then what we did was to compare our signatures, with the literature, the information from the literature. So what we see here in the letters, correspond to the to Antarctica, to the Western Antarctica, to Patagonia. I mean, from the soils, from the riverbed, and even from the aeolian dust here, from southern Patagonia also, from Patagonian, specific Patagonian river where we found some information, from the Paraná River and Uruguay River, that these rivers, the Paraná River corresponds to 70% of the river discharge in the Rio de la Plata, and Uruguay River corresponds to 30% of the discharge. And from a river from Southeast Brazil, and other sources of sediments from Southeast Brazil. I mean, all of those, this river, as well as this river crosses Precambrian rocks, and these are signatures of rocks from Southeast Brazil, from Precambrian rocks from Southeast Brazil. And here we plot our samples. So this means that we wanted to trace, and we wanted to check using the epsilon neodymium and lead isotopes if we were able to recognize the sources of the sediments. Well, when we work separately with the samples from the south, I mean from the Rio de la Plata, from the Uruguay, and from the Argentina, so from 35 to 55, one aspect which is important is that what we see here in the deepest area is that the signature of the samples from the deepest area, I must say, deeper than 2,000 meters, is different than the signature from the Patagonian, so the Argentinian. And when we analyze this and we compare with the paper by Roy, 2007, we see that the signature from the deepest area in this region is more similar to the sediments from the west to the Antarctic Peninsula and West Antarctica than from the sediments from the Patagonian. And it's almost clear for us that the sediments from Patagonian have an Andean signature. So we must say that in the deepest area, we don't recognize the Andean signature in the sediments. We don't recognize, but what we see is a signature which is different and much more similar to that of Antarctica. So, and these are the samples from the Rio de la Plata. These are the samples from the Rio de la Plata that exhibit a signature also, which is different than from the Andes, okay? So the sediments from the Rio de la Plata are more negative than the sediments from Patagonia, from the Andes. Well, we wanted to try to check if those oceanic fronts, if they can also act as geochemical boundaries. And for that, we have, as I told you, we have a physical oceanographer, very, very good oceanographer, that ran a model which is the echo. It's called echo reanalysis, and used 16 years of observations and focused in two areas. First of all, he focused in the area close to the Uruguay region, to the subtropical shelf front. And here we can see the subtropical shelf front in this, which is marked by a temperature gradient from coldest waters here to warmest waters in this area. And here we can see also, so this is a transect. This is a transect of the shelf. And here we can see also the coldest waters close to the 40-meter isobars, and with a boundary, a very, very marked boundary, with the warmest waters that come from the north, okay? And also we wanted to check the second front, which is the Santos bifurcation. And the Santos bifurcation, what we see here at intermediate waters is that this water is moving to the north. This water, this is from 24 latitude to 29. So to the north of 26 degrees, we have waters moving to the north and waters moving to the south here. So this corresponds to the Santos bifurcation. When we add the results of these models to the isotopic signature, what we see here is that this is the Santos bifurcation here, and we see that the signature to the north is totally different than the signature to the south. And also we see here that the subtropical shelf front marks another boundary between these sediments from Argentina, and other sediments here. So actually, we can state that this subtropical front, as well as the Santos boundary, they correspond to geochemical boundaries, and they also control the distribution of sediments. One aspect that must be observed is that, as I told you before, the Plata plume water flows to the north. It's not impeded by the subtropical front due to the shallow displacement of this Plata plume water. And then we can state that the Plata plume water moves at least to 29, 30 degrees south here. So in other works that we are working, in another studies that we are working, we identified a zone of preferred clinoform conditions, which is located in this area. And when you see this area, it is evident that we have at least for the shelf, we have a mixture from sources from the north and sources from the south. So what we argue here is that these clinoforms are fed either by sediments from the Plata or by sediments that come from the north, from the Brazilian margin. So then finally, we propose a model for the source. We have a main source here, which is the Rio de la Plata. The Rio de la Plata contributes with most of the sediments from the Uruguay, from southern Brazil, and also part of it is transported to offshore in this region. Apparently, the maximum range of the Rio de la Plata plume is about 28, 29 degrees here. We have small sources in Argentina that correspond to the rivers, but also correspond to the Andean sediments transported by wind. Of course, we have a important source here of sediments coming along this Argentinian shelf, because we have several sources here. But in deeper areas, what we have here is a source that comes from Antarctica, so very, very far from this zone. And one aspect is that we argue is that these flows, these sediments from Argentina, they don't cross the subtropical shelf front, but they are deflected towards the east due to the movement of the Malvinas current here. And finally, the sediments that are originated from the Precambrian rocks, they have small sources, very, very small sources, but a number of sources in the small rivers of southeastern Brazil, but they are mostly transported from farther north, from the eastern Brazilian margin, carried by the Brazil current. And then the Brazil current together with the Plata plume, is responsible for the sediments that are deposited on the Brazilian upper margin. I must say that this is a qualitative model. We didn't put numbers in it, okay? So in conclusions, so Andean and continental Patagonian sediments are the main source for the deposits of the Argentinian and Uruguayan shelves, while the lower slope is more influenced by more distant sources, such as the Antarctic Peninsula. The Rio de la Plata is recognized as the main influencer of the sediments of southern Brazil up to 27-28 parallel. Precambrian terrains from east and southeast Brazil are the main sources of the sediments deposited further north. There is a mixing zone between 28 and 34 that receives sediments from both Plata and Precambrian zones. And then finally, we propose that the main oceanographic boundaries of the southwestern South Atlantic margin, the subtropical shelf front and the Santos bifurcation, they also act as limit of distinct geochemical provinces. So I thank you so much for your attention. Sorry for my very, very poor English. And so here you have my contacts and my acknowledgements to the crew of our research vessel and for the funding by 2 agencies from Brazil. Thank you so much.
Thank you, Michel. Michel, your English is fantastic.
No.
That's great. Okay, thank you. That's a really, really great talk. And other talk in the South America, because there's already a couple talks about Amazon, but the La Plata, this is the first one. Hopefully we have a couple more in the near future. And the one thing really amazing. Okay, for the audience, if you have a question, please get ready to ask. And so, Michel, I have a quick question. So you showed that you said the sediment could travel all the way from the river mouth. River mouth is the 35 degree,
yes,
and to
yes.
all the way to 27 degree to the
yes.
north. This is
yes.
This is more than 800 kilometers.
Yes, indeed. And you know, this was the Plata plume water is something that it's amazing, because first of all, I must say that this Plata plume water is wind controlled.
Yeah.
So during it's displaced farther to the north when we have southerly winds. That means during winter conditions. And but it can be measured. It can be measured physically, measured up to 27 degrees South. That's true.
That's very good. So,
yes.
But do you know how thick of the sediment on the shelf on a long way? The reason I ask, because you might know, Uri also talk about the Nile River, the longshore transport all the way from Egypt to Haifa. And we studied the Mekong, the Yangtze, the many large river systems that longshore drifting.
Yes, yes. We have some shallow seismic lines. We have some shallow seismic lines, and what we see there is that the thickness is variable, because actually the sediments are deposited in paleo depressions, you know. So
okay.
But in some of these paleo depressions, we can have up to, let's say, 10 meters of sediment.
Okay.
But in some other places you have a relict sediment, so you don't have sediments at all.
Yes.
And this is, for instance, there is another subject that we are working on the outer shelf. Due to the Brazil current, you have the maintenance of more than 1,000 kilometers of relict sediments on the outer shelf. But this is to the outer shelf. So these sediments from the Plata, they remain deposited on the inner shelf or the middle shelf, but they are not deposited on the outer shelf.
Because the plume indicator kind of within water depths of 50 meters, 30, 40, inner or middle shelf.
Yes.
That's very interesting. That's, because this river, just like the magnitude of the Mekong, is 160 million ton sediment. But anyway, I'll give an opportunity to the audience. I have many, many colleagues here. Okay, go ahead. If you have any question, just unmute yourself or raise your hand or whatever, speak. Okay, go ahead.
Can I ask?
Sure.
Yeah. Oh, so Michel, thank you so much.
Difficult questions, Uri.
Yeah, only difficult ones, yes. First of all, it's a great compilation and it's very interesting. And the first time that I see that there's a contribution from Antarctica, which is very interesting. And so if you can say a few words about that, because the journey, the sediments are going through from Antarctica all the way to the Argentina basin is difficult.
No, actually, this is not, well, first of all, the water masses that move on the middle and lower slope of Argentina, these water masses come from Antarctica. And another potential source is ice rafted debris. Because the limit of the action of the icebergs is, let's say, it's 37 degrees south. Yeah. So it's not impossible that you have sediments being carried by flows, either from surface or from the bottom. Okay, so the lower circumpolar deep water and the upper circumpolar deep water that flow along these isobeds, they can carry sediments. They are active carrying sediments. So these are water masses that are generated in Antarctica.
Can you see? Okay, and two more questions. The difficult one is the last one. You show the Paraná is responsible for a large portion of the sedimentation that goes along the continental margin, and it's nice until a certain area. Can you see the sediments variations in the supply over time?
Yes, actually. There is a PhD student. I was her co-advisor, and she worked with neodymium variations in cores. And the problem is that the cores she worked, they range from the mid Holocene to the late Holocene, but even though there are some variations along these cores, but I am sure that if we go further to offshore, let's say to the region of the Santos bifurcation, and if we get cores that go up to the last glacial maximum, for instance, we can have important variations, And one aspect that I didn't comment is the fact that some authors in the past proposed that the mouth of the Rio de la Plata during the last glacial maximum was located in front of Brazil, not in front of Uruguay. So.
Okay, and the one last question, and I don't know if you have an answer for this. When you look at the continental shelf, south of Rio de Janeiro, it's quite narrow. When you look offshore Uruguay, it's, narrow in the South American terms, and offshore Uruguay also. But if you look at the shelf offshore Sao Paulo in the turn, it's the widest. But as you show, the Paraná is the great contributor, and the sediments are going to a certain extent, not all the way. So how come widest shelf is over there, further north.
Well, you know that this area is very, very complicated because you have uplifts there, and you had also a strong salt tectonics in this area, and
so that's why it is elevated. Okay.
I mean, to the south tectonics might change the width of the whole margin, you know,
okay.
of the whole margin. And,
okay. Thank you.
But I must, you know, as you know, that there is no big source of sediments in the area.
Yes. Yes.
So
okay.
the control is more tectonic than fluvial. Okay.
Okay.
So somebody asked about the
Gabriel, you want to speak, or you just?
Okay, thank you. Well, I just felt if I posted it is better. Well, thank you, Prof, for the presentation. I am more interested in the ocean gyre as a circulation, and because you said it actually influenced the sediment distributions, and definitely there will be some water interface interactions even with the source of the sediment coming from the rivers, from the plateau. How prominent is this, their signature? I mean this because it's as if you have two sources now. There is the geochemistry of the ocean and the pre-Cambrian rocks that you mentioned from the hinterlands. Which is more prominent? I think that's just my question.
Okay, so it depends on the area, but anyway, what we see very, very clearly, I will talk about the two main ocean, I will talk about two fronts, okay? And these fronts, they are originated due to the ocean circulation. So the first front is the Santos bifurcation, that this Santos bifurcation, it's a front that occurs at intermediate waters, okay? And this is related to the subtropical gyre. It's strongly controlled by the subtropical gyre. When the subtropical, and this is a unique situation in the Atlantic, when the subtropical gyre in its move towards the west, it reaches the South American margin, and it bifurcates. And what we see there is that to the north of bifurcation, we have one signature. To the south of the bifurcation, we have another signature. So I must say that in the case of the Santos bifurcation, the ocean circulation is the main factor that controls the signature. Okay. To the more shallow, we have the subtropical shelf front. In this case of the subtropical shelf front, what we argue is that the front impedes the transportation of waters from Argentina, waters and sediments from Argentina towards the north. And then we argue that this sediment is transported when the water reaches the front. It is transported, and it finds the water that comes from the north, and then the sediments are deflected to the east, and they will feed the Brazil-Malvinas confluence. Okay, so I must say that in both cases, the circulation is the main factor for the distribution. Okay.
Yeah. Wonderful, particularly for the high sea level, high stand. And that's very true. So anybody have any question or comments? Alberto, you have any comment? Oh, Christoph Hein, you have a question?
No, we just say hello.
Okay. So,
well, I have a question for you as well, Mahik. Nice to see you. Sorry. Sorry to disappoint you. No, I actually was very interested in your response to the other question, thinking about periods of lower sea level and where the river may have extended. So I'd love to hear your thoughts on the relative influence of the Plata at lower stages of sea level. And maybe you could guess where this might be going, is the sand side of the component and the tremendous volumes of sand along the southern Brazilian coast, and whether you think the Plata is a source. And if, especially considering, as you noted, it may have been pumping out those sediments directly onto the shelf much further north than it exports today.
Yeah.
Thanks.
Well, first of all, I must say that I never worked in this area, but anyway, there is a feature on the southern Brazil margin, which is called the Rio Grande Cone. Let's say 30 or 40 years ago, some geologists from Brazil and Argentina, they proposed that feature, the Rio Grande Cone, actually represented the paleo delta of the Rio de la Plata. So what we see nowadays, is that in the inner Uruguayan shelf, you have a channel. Then it's a channel that follows it's parallel to the Uruguayan coast. We were able to identify that channel in the border of Uruguay and Brazil, but we did some shallow seismic, but in the next line, we didn't find that channel anymore. Okay, so maybe it was covered by sediments, it was reworked by the dynamics. Okay, but if we accept this as valid, we should move the whole system towards the north. But one aspect that must be observed is that this cone is a very, very beautiful feature. You see in the maps, in the bathymetrical maps. But in that case, you would transport sediments directly towards the slope.
Mm.
Okay. So, but also, of course, you will have a transport of sand and muds, and the muds would be transported towards the slope. So there will be somehow a lack of sediments towards the north, because you will not have a plata plume. The plata plume would go directly to the slope or to the outer shelf, you know. So in this situation, if we assume this is valid for the last glacial, we would have a totally completely different situation, because you would have everything displaced towards the north. Okay. I don't know if I respond to your question, but anyway.
You did, and any follow-ups, I'll bug you later. So thank you very much. It was a great talk. Appreciate it.
My pleasure.
Very good. So anybody else? So Michel, let me ask a logistic question. If we want to propose a collaboration, survey all the way from the river mouth all the way to the north, and so I guess we have to work with Argentina and Uruguay, and Brazil to get the three sides together. Or
well, actually, I already have collaboration with those colleagues from Argentina and Uruguay. The main problem is that, for instance, we already tried to bring the Brazilian vessel to Uruguay, and we had some problems. But anyway, this can be done because there are already some international projects, and which encompass Argentina. You must find researchers there. But anyway, with Argentina, with Uruguay and Brazil, and there was already some works from Germany, from the University of Bremen, who worked with people from those countries, and from there is a group of physical oceanographers who work with Argentinian, Uruguayan, Brazilian, and people from the United States, from the if I'm not wrong, from NOAA.
Okay. Okay.
But
Yeah, we can talk about more. I mean, it's a very interesting, you know, this system, you know, because this is the second largest longshore transport behind the Amazon, but this is relatively not that much studied compared to Amazon. But so, yeah, very good. So, okay, if no any other question, and I think Michel, you already. I guess you can see the chat, so people like your talk very much, and in the chat room. And so, okay, if no any other question or comments, so we can end it here. But once again, this coming Friday, as I mentioned, we have other talk given by Professor Carl Stetic. So please do not miss this talk. It's also talk about the Brazil South Francisco River. Okay, so I'll see you, most of you, on Friday, the same time. Okay, so long. Thank you, Michel. It's fantastic.
Thank you so much. Thank you. My pleasure.
Okay. Bye,
bye, Alberto. Bye, Uri. Bye, Chris. Bye, Saito-san.
Bye-bye.